let's refresh our memories on the exponential function. We've got three different parameters that we need to consider. Our a, which is our coefficient, our b, which is the base of our exponent x, which is how we can easily identify our exponential function, that x is part of the exponent. And then we are adding a q, which just represents a number, a 2, a 3, a -5, whatever, it doesn't matter. All right, so you need to identify that standard form. You must know that standard form. What we're quickly going to do is we are just going to change to those parameters. We are going to change to the a value and see how that affects our graph. We're going to change to the b value and see what that means for our graph, and then the same for our q value. All right, let's jump in. At the moment, we've got an a value of 1, a b value of 2, and a q value of 0. Now, just like with our other functions, let's start with the q because that just moves it up and down. With our exponential, we also have a horizontal asymptote. Let's change to the q. At the moment, my q is 1. I made my q 1. Then it means the whole graph moves 1 up. So my asymptote will be there. My asymptote will be by 1. And note there that my y-intercept is now by 2, where it used to be by 1 when my q was 0. All right? If I move it further up, if my q is 2, the asymptote will be by 2. There you go. And if my q is -2, then the asymptote will be by -2. All right, so q moving it up or down, and it also gives you your horizontal asymptote. Now I'm going to go back. I'm just quickly going to go make my q 0 again. So my asymptote is by 0. Now I'm going to change to my b value, my base of my exponent x. And there are some restrictions on our b. All right, let's explore that. At the moment, my b is 2, as you can see. I'm going to make it bigger. I'm going to make it 2.9, there it's 3. Can you see that it does not affect our y-intercept? Our y-intercept stays 1, but it just seems to grow faster. It just seems to, can we call it more steep? The bigger the b gets, but note that the whole graph is increasing. As my x values are increasing, my y values are also increasing. That's why it is called an increasing function. All right, let's have a look. If my b is between, notice what happens when my b is 1. It falls flat. It's just a straight line. Why does that happen? Because 1 to the power of anything just gives you 1. So it won't give us an exponential curve if our b is 1. So our b can't be 1. But notice that b can be between 0 and 1. It's a fraction. That would be 8/10, which would be 4/5, right? So when my b is a fraction between 0 and 1, my graph is decreasing. Do you see that? So if my b is between 0 and 1, my graph is decreasing. My b can't be 1, but if my b is bigger than 1, it increases. So bigger than 1 increases, a fraction, so between 0 and 1, it decreases. B also can't be 0. The graph won't exist when my b is 0. So b can also not be negative. The graph won't form an exponential curve when my b is a negative value. So quite a lot of restrictions on b. B can't be negative. B can't be 0. But b can be between 0 and 1, a fraction. Then we know it will decrease. B can't be 1, but it can be bigger than 1. All right, that's stuff that you need to know. Let's make b 2 for now. And then let's quickly change to parameter a, the coefficient of b to the power of x. All right, note what happens. As I make my a bigger, it affects my x-intercept. So if my a is 2, not my x-intercept, my y-intercept. As my a is 2, my y cuts by 2. So my a affects my y-intercept. All right, there my a is positive. Look what happens when my a is negative. It goes down. A positive, a negative. So I remember it like if my a is positive, my graph will be above the asymptote. And if my a is negative, my graph will be below the asymptote. Now let's change to a few of these parameters. Let's make our a 2. Let's make our b a fraction. Let's make it a half. And let's make our a Currently my A is positive 2. Now I already changed to my A. Let's make our Q negative. So if our Q is now moving down to -1, note that my asymptote is by -1 and now an x-intercept exists. How are we going to find x-intercepts? We're just going to make our y 0. And if I move it up, let's say my Q is 2. There's no x-intercept. The x-intercept does not exist. And my asymptote is positive 2. All right. Now we need to apply all of our knowledge. Let's work through 4 different questions. It says that we need to draw a rough sketch of the following. Now, yes, they told us this is an exponential section, but we need to be able to identify that as an exponential graph. Our x is part of the exponent. All right. Then it gives us that a is smaller than 0. So it means that a is going to be a negative value. That needs to mean something to you. Then this means that b is between 1 and 0 because it says b is bigger than 0, but b is smaller than 1. So b is between 0 and 1. So that must make b a fraction, something like a half. Remember, there are some restrictions on b. B can't be negative, b can't be 0, and b can't be equal to 1. And then it gives us that q is smaller than 0. Q is smaller than 0, so it means that Q will be negative. Cheapest. Okay, so now we need to take all of that into consideration, and we need to make a rough sketch of more or less what this graph would look like. Okay, let's do it one thing at a time. Let's think about Q first. So that gives us our horizontal asymptote, and Q must be negative. So that means that our Q is a negative value, so it moved down. Okay, so I'm putting in that asymptote. I think that's a good place to start. So we looked at that one. Then, what does it mean when it says that A is smaller than 0? So that coefficient over there, that A is negative. When we explored, we saw that that means that my curve will actually be below the asymptote. So we know that this curve is going to be there. All right, so that's done and dusted. And then when my b is a fraction, it means that my graph will be a decreasing curve like that. Okay, but we just said that it will be below the asymptote. So why am I drawing that one in? Well, I'm just making it easier for myself. When this one is decreasing like that, the curve that would be below the asymptote is a mirror image, is reflected about that asymptote. So there is the correct curve of where our graph that we are supposed to draw will be. Okay, so I'm just getting rid of all of that. I can also get rid of that. And there it is. There is a rough sketch considering the information of A, B, and Q that they gave us. Sure. Okay, next one. Sketch the graph of y is equal to, okay, let me just copy that one over. They want us to go sketch this graph. Okay, we can do that. Let's go identify that is our Q value. So our vertical shift up or down, which gives us our horizontal asymptote. Then there is our A value. There's our A value that we know if that is positive, it will be above the asymptote. If it's negative, it will be below the asymptote. And then there is our B value, which in this case is a fraction. And that also needs to mean something to you. All right, let's go put in our horizontal asymptote. That's by -1, so it will go there. There's the asymptote. It's the line y is equal to -1. Okay, now just be mindful. With our exponential curve, we will be able to find our y-intercept, but we're not always able to find the x-intercepts. And that's okay if we're not. So I'm just going to go through this with you and show you why we can't find the x-intercept. And sometimes you will be able to find it. So I hope that I can just highlight that to you clearly in this example. So let's just quickly see, since our b is a fraction, it means it's something that will be decreasing like that. And since the curve moved down, and because of our a value, it will be above the asymptote, our curve will be somewhere over there. So that means that, yes, it does cut the y-axis, and yes, it does cut the x-axis, but we are able to calculate the y-intercept And we have to check. It depends on the graph if we would be able to calculate the x-intercept or not. So I'm going to show you what to do when you can't find the x-intercept. And I'm going to show you how you know, like, okay, wait, I won't be able to find the x-intercept with this. So please bear with me for this example. So let's draw a proper graph. We've got the asymptote in there. Let's go find the y-intercept. We are going to find the y-intercept by making our x 0. So y is equal to 2 times a third to the power of 0, and we take away 1. Now, the purpose of this is just to draw our graph. So obviously, it's fine if we go plug that into our calculators. But do you notice there that a third to the power of 0 is just equal to 1? So it will be 2 times 1, and we take away 1, so that will just be 1. So when we made our x 0, our y is 1, and that gives us our y-intercept, which is over there. Okay, now let's get to this x-intercept dilemma. So to find the x-intercept for any of your curves, you just make your y equal to 0. Let's go do that. 0 is equal to 2 times a third x and then minus 1. Okay, now we have to solve this equation. This is some exponential equation knowledge that we need with this. So I'm going to take my 1 over. Now we are there. Then I'm going to divide both sides by 2. And when you get to this point, this is the point where you know I am not going to be able to calculate my x-intercept because in grade 10, you don't have the knowledge of how to solve an exponential equation where you can't make the basis the same. And I'm going to show you just now where you will be able to find the x-intercept. So when you get to something like that and you see, oh, I'm never going to be able to make a half and a third the same base, then you stop and you know, okay, I can't find my x-intercept. That's okay. We're just going to find 2 other points that we're going to plot. And we're going to do that in a moment using a table. But let me just also show you that sometimes you will be able to get your x-intercept when the equation looks slightly different. So for this curve, we won't be able to find the x-intercepts. The grade 12s will be able to find the x-intercepts when they are going to use logs. But for now, you're not going to be able to do that, and be okay with that. I'm sorry. Okay, let me just show you an equation of where you will be able to find the x-intercept. So just bear with me. 2 to the power of x, and then take away 4. Let's say we were given an exponential curve like that. I just made that one up. This has nothing to do with the one that we are busy with right now. I just want to show you a different one where you will be able to find your x-intercept. To find the x-intercept, we make our y 0, right? So in this case, if we make our y 0, we get to that point, and then we take the 4 over, and now we are there. You do have the knowledge with your exponential equations of how to solve that. You make the basis the same. 4 you can write as 2 squared, and there is 2 to the power of x. So now that my bases are the same, my exponents have no choice. They must be the same thing. So therefore, your x is equal to 2. So this curve over here will have an x-intercept of 2. So with that one, we can go plot it. But with the one that we are looking at right now, we can't find the x-intercept. We are okay with that. What do we do then? We go plot 2 other points that we can go plot on the Cartesian plane to show where our curve would lie. So I think I'm going to choose for my x just 1, and then a negative 1, a positive and a negative point. So we can plot a point on there and also on that side. So I just chose 1 and negative 1. So into the place of x, I am going to substitute a 1. Let me show you. Y is equal to 2 and then a third to the power of 1, and then we take away 1. So when we do that, that is just 2 over 3, and then we take away 1. I'm going to reach for my calculator. And that should be negative 1 over 3. Negative 1 over 3. And then if we go plug in, x is equal to negative 1. Let's see what we get when we do that. When we plug that in, you can also just put it into your calculator. That gives us 5. So now we can just go plot those points. So when my x is minus 1, my y is 5. When my x is minus 1, my y is 5. 1, 2, 3, 4, 5. There we go. And when my x is positive 1, my y is equal to negative a third, which is somewhere over there. Perfect. And there we have our curve. It goes towards the asymptote but never cuts it, and there's our exponential curve. All right, so I wanted to do this example with you just to show you, like, sometimes you won't be able to find your x-intercept, sometimes you will, so always go check for it. Don't feel when you're trying to find the x-intercept and you get stuck like we did over there that you now start panicking and thinking you're doing something wrong. There's nothing wrong with you. Question 3 says, find the equation of the following function. When you look at that, you must immediately be able to identify that as an exponential and then know that it would look like that. B to the power of x plus q. Let's see which points over there we can use. If I look at this, it looks like our asymptote is there by negative 4, so we can plug that in there. Y is equal to a times b to the power of x and then minus 4. Okay, so we found q. Now we still need to find our a and our b. The fact that there's still 2 missing perimeters makes it quite challenging. But a good tip over there is start by substituting the y-intercept in. And the reason why that is a good one is if we plug in that point 0 and minus 3, see what happens. In the place of y, there's negative 3, and then we've got a times b to the power of 0. Do you see why it's a good idea to plug in our y-intercept? Because when we do that, our x is 0, and then that b to the power of 0 becomes 1. Negative 3, and there we've got a times 1, it's just a, and take away 4. So that puts us in a position where we can find the value of a. If we get a by itself, it means we're going to plus 4 on both sides, so a is equal to 1. Okay, great, so far so good. So let's go put in what we found. We know that a is 1. We know that q is negative 4, and now we only have the b that we need to find. So where's another point that we can substitute? Well, let's just substitute that point in. It's given the x-intercept, which is by 2 and 0. So when my y is 0 and my x is 2, then we can solve that one. So however you prefer to solve that, you can take the 4 over and get the square root on both sides. I am going to use dots just because I like to do that. So then my b is equal to plus or minus 2. All right, and then we need to decide. So which one is b? Is it now plus or minus 2? You need to know that my b, my base to my exponent of x there, cannot have a negative value. So therefore, our b is equal to positive 2. And there's our equation. Y is equal to, our a is 1, our b is 2, and our q is 4. Last question for the exponential curve. Write down the domain and the range for graph 2 and 3. So it's the one that we drew and the one that they gave us. We need to go write down the domain and range. Let's go. Let me just create some space for the domain and the range. So for the domain, like with the other ones, we are going to position ourselves on the on the x-axis. And when we go towards the graph, if the graph exists there, if there is a solution, it means it is part of the domain. So part of the domain, and that one goes up and up and up and up and up. So if I go to this side, there will be solutions because the graph is carrying on to negative infinity. And then if we're there will be a solution. There's a solution. If we go there's a solution, and it carries on and on and on and on. So there are no restriction for our domain, for our x values. Now for our range, we are going to go position ourselves on our y-axis. We're going to go towards the graph. If solutions exist there, it's part of the range. Part of the range, part of the range, part of the range. And then as this one goes up and I go up, there will be solutions. So to positive infinity, there will be solutions. Let's move a little bit down. There, solution, 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 no solution. So where does it change? My asymptote. There aren't solutions for this graph anywhere below my asymptote. So my range would be that y must be bigger than wherever my asymptote is, which is -1. Can that -1 be included, great teens? -1 will not be included because it is the asymptote. A solution does not exist there. Okay, now for the third one. Let me just write it over there. We're going to find the domain and the range. Oops. The domain and the range for this graph. For the domain, let's go position ourselves anywhere on the x-axis. There's a solution, so it's part of the domain. Part of the domain, I'm there. Part of the domain, and that carries on. So as I'm going more and more to this side, this carries on as well. So there would be no restriction on any of the x values for the domain. So domain is x is an element of real numbers. Let's look at our range. Let's position ourselves on the y-axis, go towards the graph, and see if there are solutions. So if I'm there, go towards the graph, solution, solution, part of the range, solution, part of the range, solution, part of the range. If I go up, yeah, that will be part of the range. That goes up as I go up. So all of that is part of the range. Where does it stop? There by the asymptote. If I go below the asymptote, the graph does not exist there. There are no solutions. So y must be bigger. Y must be bigger than -4. That's where the asymptote is. Can -4 be included? No, it's the asymptote and solution does not exist there. I know that exponential function seems like a lot, but I know that you can do it. Just keep at it and try some on your own, and I hope it goes really well. If not, ask for help.